So good afternoon everyone. Myself Asit Mondal, Assistant Professor of Electrical Engineering Department. So today I am going to deliver a lecture on the topic the structure of electrical power system. So before going to the topic, first of all, why we go for the structure of power system and what is the objective? So we all know that the electrical energy is very much essential and convenient in our daily life, because from starting from the morning to night, everywhere and every activity it is used. So suppose in this room the voltage level is how much? The voltage is 230 volt, single phase voltage. And same way in industry the voltage, the load is 3-phase load, and the 3-phase load voltage is 400 volt or 415 volt, somewhere the 11 kV voltage or 33 kV voltage. So what is the main source of voltage? So you know that the main source is the generating station. But is the generator generate the defined amount of voltage? No. There is a fixed amount of voltage, then after some stages the voltage is step up, step down, then as a consumer we get the defined voltage. So everything will be included in this session. So first of all, power system. So what is power system? Power system means it is a total arrangement from generation to distribution through the transmission. So if you look this figure, here the first part is the generation, then transmission, then distribution, then the load. Load means the our side. So we are the domestic load consumer, then the industrial load consumer. So generation means what? Where the power is generated. Like there are different type of power generating station is there, like thermal power station, hydel power station, means the hydroelectric power station, nuclear power station, etc. Then this power transmit through long distance by this type of tower. I think all of you have seen this type of tower, and this tower is used to transmit the power from one place to another place, means from generating station to the load center. Why? Because normally the generating station is placed or situated in very far away from the load center. And next, at the receiving station there is a substation is there, then from the substation the load is distributed at the different section, a different type of load. So next, so before going to the details, first of all the installed generation capacity in our India dated 30th June 2022. So if you see this figure here, you will see that the maximum amount of energy generated by the fossil fuels. Fossil fuel means, here it is mentioned, the fossil fuel means there may be coal, lignite, gas, diesel, all are under the fossil fuels. And this fuel is used in the thermal power plant. Means what? In the thermal power plant, this thermal power plant mainly maximum amount of power generated. 58% of power generated from the thermal power plants. And next, 28% power generated by the renewable sources. Renewable source means there may be wind, solar and other renewable source. This one. Approx 28% power generated in India from the renewable sources. And after that, the 12% of energy, electrical energy generated from the what? From the hydroelectric power plant. Hydroelectric means where the water is used for generate the power. I will discuss later how the power is generated. And rest 2% of electricity generated from the nuclear power station. Nuclear. Here the power approx power generation is 2% or 1.7%. So this is the total scenario of the power generation capacity in our India. And the total generation capacity in India is how much? 4,03,760 megawatt or approx 400 gigawatt. This is the total installed capacity in our India. Next, Genco, Transco and Discom. So what are these? These all are the companies which is involved in business for generation, transmission and distribution. These all are the company which is involved for business purpose, for generation, transmission and distribution. Suppose Genco means what? Genco is the generation company which is involved for the business of the generation of power. And the example of Genco, NTPC, NHPC, etc. NTPC means what? The National Thermal Power Corporation. And NHPC, National Hydro Power Corporation. Means here the thermal power station is there. Here under this NHPC, the hydro power plant is there. Same way Transco is the transmission company. transmission company, and the example of the transco is what? PGCIL, Power Grid Corporation of India Limited, and same way DTL. So this is the transco or transmission company. Same way the discom is there for distribution company. So these all are the company which is who are involved for generation, transmission, and distribution. Next the energy conversion process. Energy conversion process means how the energy, means the electrical energy is generated. But how ultimately we will get the electrical energy. There is a process. So the main basic process is what? We know that the electrical energy is generated. Here the electrical energy means mainly here we are talking about the AC energy, AC electrical power, AC power. So here ultimately the alternator or generator is used to generate the power. We all know that, where the mechanical energy is converted to the electrical energy by the help of prime mover. So here prime mover means there are different type of turbine, and the input of the turbine may be different source of energy. I will discuss in the next slide what are the form of or different source of energy. So how the alternator generates the power? So you all know that the alternator, suppose this is one alternator and suppose this is the rotor. And you all know that the rotor are DC excited. In the rotor there is a DC excitation is there, and this is the stator. Stator part is there in every machine, or there is two parts, stator and this part is the rotor. And this rotor are coupled to the turbine. Also you can represent like the turbine blade, like this. So this is turbine. So for generating the power from the alternator, somehow we have to rotate this rotor of the alternator. So how? By the help of steam, by the help of water, we rotate the turbine, and the turbine shaft and the alternator rotor are coupled each other. And whenever the turbine rotate means the alternator rotor also rotate, and ultimately the magnetic field cut by the stator conductor of the alternator, and then the EMF is induced on the stator conductor or the armature conductor, and then from the armature we will get the three-phase supply. I mean, ultimately somehow we have to rotate the rotor of the alternator by the help of turbine. And here the turbine, if you see this figure, here this is the turbine blade. If you provide the high pressure steam to the turbine blade, then what happens? The turbine blade rotate. Whenever the blade rotate means total shaft rotate, and the turbine shaft coupled to the alternator rotor, then the alternator rotor rotate, and from the stator of the alternator or generator we get the three-phase output power. And this turbine rotate by the help of water also in case of hydroelectric power plant, and in case of thermal power plant by the help of steam the turbine blade will rotate. So in this way we will get the three-phase supply. The supply is three-phase, not single phase. Always in the power plant the generated supply is three-phase in nature. Next, the power generation type. There are two type of mainly source of power. First one is the conventional source. Next, second one is the non-conventional source. Also, you can say renewable source and non-renewable source. So, conventional source means the thermal power plant, hydroelectric power plant, and nuclear power plant. Actually, we have already know that in our India mainly the power generated, approx 60% power generated from the thermal power plant. In thermal power plant means where the heat is used. Heat means the heat produced by the coal is used to generate the steam, and this steam is used to rotate the turbine blade. So that's why this is the thermal power plant. In case of hydroelectric power plant, the flow of water, the water flow is used to rotate the turbine blade. In case of nuclear power plant, again here the heat is used. In the nuclear reactor there is a uranium is used to generate the heat, and this heat again produce some steam, and this steam strike the turbine blade and the turbine rotate. And in case of non-conventional source of energy, there are wind, solar, biomass, etc. Next is the major component of power system. Very important, major component of power system. In the power system, actually power system is a very much, it is a vast topic in electrical engineering, vast topic. So major component is what? generator, power transformer, transmission line and substation. So first the generator. So here you see that these all are the generator. In the substation, suppose this is the one thermal power station, generating station. So in the generating station there are more than 2-3 number of generator is there, and all the generator are coupled to the turbine's rotor or the turbine shaft. So generator you used to generate the power. Same way, next is the power transformer. What is the function of this power transformer? Before that, what is transformer? We all know that transformer is a static electromagnetic device which transforms the power from one circuit to another circuit without change the power and frequency, just changing the voltage or current. Means what? We all know that in the transformer there is a core. Core may be made of soft iron or silicon steel. There is a primary side and there is a secondary side. By changing the number of turn in the secondary side, we can change the voltage level. Suppose here the voltage is 11 kV. If we increase the number of turn in the secondary, we will get suppose 33 kV voltage. So by changing the number of turn in the secondary side, we can change the voltage. So next part is the transmission line. So we have already seen the transmission line. So transmission line, what is the function of transmission line? This transmission line is used to transmit the power from generating station to the load center, because we all know that normally the generating station are very far away from the load center. So for transmit the power through this long distance, this transmission line is used. So these are the tower and these are the line. And in the transmission line there are some component is there like the line, tower, insulator, damper, vibrator, everything is there. So you will know later. Next part is the substation. This is a very important part in a power system, because in the substation you will see that there is a transformer is there, transformer, and this transformer is used to step up or step down the voltage according to our load requirement. And in the substation, not only the transformer is there is some protective device also there, circuit breaker, relay, etc. And the isolator is there. And for measuring the voltage, how much amount of voltage is there, for measuring voltage and current, there is a PT, CT. PT, CT means the potential transformer, current transformer, circuit breaker, relay, lots of devices there in the substation. So very important part in a power system, substation. So you will learn later. Next, the electrical power system load. The load of a power system. Actually, we are under the residential load. Load means what? Because in our home there are different equipment is there, electrical appliances is there who consume the electric power or electrical energy. So there is a residential load, commercial load, industrial load, agriculture and municipal load, and the traction load. There are different type of load, and all the loads require different type of voltage level also. And this voltage level, who will provide this voltage level? There are different stages of the transformer is there. This transformer step down the different level of voltage according to our load requirement. So in the residential load means the light, fan, refrigerator, heater, television, TV, water pump, everything which is used in our residential or domestic purpose. And commercial load means commercial purpose, means the shopping mall, restaurant, etc. Industrial load means there are different type of industries there. Suppose some industry require 11 kV voltage, some industry require 33 kV, or in large scale industry require 66 kV voltage. So for different size of industry, different level of voltage is required. This is the agricultural load for pumping of water, municipal load and traction load. This is the basic structure, the main topic, basic structure of power system. So we all know that the power is generated in the power plant or generating station. Suppose this one is the generating station, power plant, where the power is generated. Then after the generation, there is a transformer is there, step up transformer, step up the voltage. Suppose from 11 kV voltage generated, the step up transformer step up the voltage from 11 kV to 132 kV, 32 kV. And this high amount of voltage is transmitted through the transmission line and tower. Transmit to a tower, and after some long distance there is a transmission substation is there. So in the substation then the voltage will step down then the voltage will be stepped down in the substation, step down to different voltage level, suppose 6 kV voltage level. Then what happened? Again this voltage, then again this voltage level of the power transmit through the line or tower. Again another substation is there. This is the distribution substation, and this substation is located nearby your locality, nearby the load center. Again here the voltage is step down, means first the voltage is step up, then after that the voltage is stepping down one by one. Then again there is a distribution pole is there, then ultimately the load means the domestic load. There may be, here may be some small industrial load. From here suppose one large industry is there, large industry is there, who take 66 kV voltage. So in this way the power is or the load is there, and the different level of voltage distribute the load. This is the basic structure. In the next slide I will show you the exact voltage level, different voltage level. So this is the single line diagram of the power system. Single line diagram. From here you will see that how the voltage level is changes from different stages. So first of all, suppose this is one generating station where three number of three number of generator is there. Any type of generating station, suppose thermal power generating station, three number of generator is there. And here in this generator, suppose this generator generate voltage is how much? 11 kV voltage. The range of voltage, generation voltage, 11 kV, 25 kV, maximum 33 kV. But in our India, mainly the maximum voltage is 25 kV. Somewhere the 33 kV. This is the maximum range of generation by the generator. Sometimes 6.6 kV also. This is the generation voltage, not high voltage. Maximum voltage is from 6.6 kV to 33 kV voltage by the generator. Then after the generation of this voltage, there is a transformer is there. This is called step up transformer. Step up transformer is there. This step up transformer is used to step up the voltage from this 11 kV or 33 kV to very high voltage or extra high voltage. And this voltage level is how much? 132 kV, 220 kV or 400 kV. So always after the generation the voltage is step up or stepping up. Why? There is advantage is there, because this high amount of voltage or high voltage is this high voltage transmission line or high voltage transfer power is transmitted through long distance. The power is transmitted through long distance by this high voltage. Why? Because we know that the apparent power is equal to what? 3 into V phase, I phase. So if the power is constant, then the current I is inversely proportional to, you can say, V. So this is the relationship. So if you increase the voltage high, then what happens? The current will reduce or decrease. So if you decrease the current, then what happens? The losses, I square R loss also will reduce. So if you decrease the loss, then what happens? If you decrease the loss, then obviously the company get more revenue, means this is more economical, and the conductor requirement also become less if you reduce the current or if you reduce the loss. For economic purpose, always the voltage is step up. Next, and another thing is that in the generation station or the generator also generate maximum 33 kV, not more than 33 kV. Why the generator generate maximum 33 kV? Here is also some limitation. Limitation is what? There is a insulation limitation. Insulation. The limitation of the insulation. The voltage level of the generator is maximum 33 kV. Next, after the 132 kV or 220 kV or 400 kV, and in India somewhere 765 kV also used for transmission of voltage. For transmission of voltage is maximum 765 kV in our India. After that, again after some distance there is another transformer is there. And first the transformer is step up, then all the transformers step down. Step down transformer is there. This transformer step down the voltage from this 132 kV or 220 kV or 400 kV to 66 kV. from this voltage to this voltage by using the step down transformer. And okay, wait. So this range, this portion up to this portion is called transmission. Up to this portion is transmission. This is the primary transmission, this is the secondary transmission voltage. Primary transmission voltage is up to from 132 kV to 765 kV, and in the secondary transmission level voltage is up to 66 kV voltage. And other things, from this voltage level, high voltage level, here the another line is going another side, and this side is what? This side is the another area or the line connected to the other grid. So grid means what? Grid. So you all know that in India there is a one nation one grid term is there. In India total there are 5 regional grid is there. Total 5 regional grids. I will discuss later. So from here the power go to other grid. Other grid means what? The grid means there is a interconnection of high voltage transmission line. Grid means the interconnection of high voltage transmission line. Suppose one area is there, this one, and another area is this one, A1, and the area, second area is A2. So in this area or in this region, what happened? There are 4-5 number of generation or generating plant is there. There are different type of generating plant. 5 number of generating plant is there, and here also some number of generating plant is there. No, where the power is generated. And these two areas is interconnected by one line. This is called tie line. Tie line is what? The line which is interconnect two area. The line which is interconnect between the two area called tie line. And what is the advantage of this tie line? Before this tie line, what happened? So before this tie line, what happened? This area A1 generates some amount of power. Suppose 100 megawatt power generated by this area, and the load demand is generation, and the load is what? Suppose 100 megawatt. But if some cases the load demand increase, load demand become suppose 150 megawatt or 150 megawatt. So what happened? The generator capacity or in this area the maximum generation capacity is 100 megawatt. How it fulfill this one extra 50 megawatt? So for that case, if there is a tie line is there, then what happened? The another area A2 will give the power to the area A1 for fulfill the load demand. Means there is a interconnection is there. This is the benefit of the interconnection. If any cases the load demand increases, the another area may give the power to the area A1. Also in some cases, if there is a fault in suppose one generator or two generator, there is a fault, then also the area A2 or in this area A2 there is a power is there, this power delivered to the load or power delivered to the area A1. So in this way the tie line is used for our convenience. Next, the voltage level. I have already told you there are different level of voltage for generation, transmission and distribution. So generating voltage is from 6.6 kV to maximum 33 kV. This is the maximum range generating voltage. Next, the transmission system. In the transmission system, the voltage level is 132 kV, 220 kV, 400 kV and 765 kV. This is the maximum range in our India. Next, the distribution. So remember, in the distribution system, the voltage starting from 33 kV is the distribution voltage. From 33 kV and 11 kV. So 33 kV voltage is maximum voltage in case of distribution is 33 kV. From the 33 kV voltage, the distribution system start. And this is the primary distribution level, and the secondary distribution level, the voltage is 400 volt or 230 volt, 400 or 415 volt. This is the three-phase voltage, and this is the single-phase voltage. And this single-phase voltage is used in our domestic purpose or in our household purpose. And the three-phase voltage is used in small industry or works of where the three-phase induction motor is there. Next, the part of distribution system. The part of distribution system. So distribution system means what? The system which is used to supply the power for local uses is called distribution system. So in the distribution system there are three parts: feeder, distributor and service main. Feeder, distributor and service main. So what is feeder? So before that, if you see the figure here, suppose this is one transformer is there. Suppose here this transformer step down the voltage from 33 to 11 kV, 11 kV voltage. So this is the transformer which step down the voltage from 33 by 11 kV, and here the power is coming from the transmission system or transmission line or secondary transmission system. So transformer step down the voltage from 33 by 11 kV. Then this 11 kV is here in the distribution substation, and from this substation the 11 kV line go to nearby your locality. This is your locality, and in every locality there is a pole mounted transformer is there. In every locality there is a pole mounted transformer. I mean, like this transformer. I think everybody seen this type of transformer. In your every locality this type of transformer is there. Pole mounted transformer. I will show you in next slide. Pole mounted transformer. So from the substation to this transformer, suppose here the substation is there. Substation to transformer. This line is called feeder. This is called feeder. So what is the main property of the feeder? From this feeder, no tapping option is there. No tapping. So I already tell the tapping are not taken from it. From the feeder, no tapping. So here this feeder, no tapping is there. And in the feeder the constant amount of current is there. As there is no tapping, the constant amount of current in the feeder. Next, after the feeder, what happens? There is a distributor is there. Distributor means this part is the distributor, which distribute the power from this transformer to the consumer, the distributor. After that, and one thing in the distributor, whenever we design the distributor, the voltage drop should be considered, because there are different tapping option is there. In case of distributor there are different tapping option is there, but in case of feeder no tapping option is there, but in distributor there are different tapping option is there. So what happened? Okay, I will discuss later. So after the distributor, the next part is what? Service main. Service main means this wire. The wire or the conductor which connect distributor and the consumer, domestic consumer, is called the service main. Only written here, the conductor which connect between the distributor to the consumer terminal. It means from distributor to consumer or from distributor to house, the wire connection is called service main. Okay, in the next slide it will be clear. Okay, and this is what the secondary electrical power distribution system. So why we discuss this topic, or why we discuss this portion only? Because we are the consumer under the secondary distribution system. Our voltage requirement is 230 volt, or in case of 3-phase 400 volt. So how we will get the 3-phase voltage 400 volt or 230 volt? So let's see. Okay, before that, if you see this figure, pole mounted distribution transformer, and I think everyone have seen this type of transformer nearby your locality, this type of transformer. So this is the distribution transformer, which is placed nearby your locality, distribution transformer. And suppose here one substation is there. From this substation the feeder line go to this distribution transformer. This is called feeder. I already discussed. This is a feeder, and normally the feeder line are this cable. This cable is the feeder. This cable is the feeder. Here no tapping option is there. This is the input of the transformer. Feeder, and after the feeder, what happens? There is a transformer, and after the transformer, there is a distributor. Distributor means what? This type of wire. This 4 wire is the distributor. This 4 wire is the distributor, and this distributor distribute the power to your locality. Suppose this one, this is the distributor. The distributor will distribute the power to your locality, and from here by using service main means this wire. Suppose this wire is the service main. This wire, from this distributor by using wire, this is called service main, the power goes to your house. House means the energy meter. In your house, every house there is an energy meter. Through this service main, the power go to your energy meter. Then in your house there is main switch is there, then MCB, lots of things is there. So in this way the single phase supply goes to your house. But how we get the single phase supply? Let's see. Suppose this one, this is the pole mounted transformer which is located in your area, and this line is the feeder line. This line is the feeder line, and this is the pole mounted transformer, step down transformer which step down the voltage from 11 kV to 400 volt. Step down the voltage 11 kV to 400 volt. And this 400 volt, what happened? Feed this 400 volt feed to nearby your locality like this: R phase, Y phase, R, Y, B, and neutral wire is there. R, Y, B, and neutral. 4 wires is coming. But in the feeder there are 3 wire: R, Y, B. But in case of distribution transformer, there is one extra wire always taken out. Extra wire is the neutral wire. Why? For single phase supply, the neutral must be considered. Without neutral, the single phase supply we cannot get. So that's why for household supply, how the single phase supply is coming from one phase. Suppose this one from one phase, and another wire from the neutral, in phase and neutral, and this voltage is called phase voltage. The voltage between the any one phase R, Y, B phase and the neutral is called single phase voltage, and the three phase voltage means the line to line voltage. So you know that the line to line voltage is what? The 400 volt. The voltage between R and Y, Y and B, or R and B, the voltage is line to line voltage or 400 volt. So, and this voltage is 230 volt. How we get this 230 volt? Because in case of star connection, we see that this transformer is the delta connection and the secondary of the transformer is star connection. So delta star connection, so secondary star. So in case of star connection, we know that there is a relationship VL equal to √3 V phase. So from here VL is the line voltage. So here the line voltage is how much? 400 volt. So line voltage 400 volt, and √3 V phase. And V phase is the single phase voltage. Single phase voltage means the voltage which is coming to your home. So from here the V phase equal to what? V phase equal to 400 by √3 means approx 230 volt. And this is the single phase voltage, and this single phase voltage, we get this single phase voltage in this way. So 400 volt means the three phase voltage, and single phase voltage means the 230 volt. Single phase means the voltage between any line and neutral. This voltage is the single phase voltage. So in this way we will get the single phase voltage, and in case of industrial load or small factory, they get the three phase power or three phase voltage from 3 wire R, Y, B, and also they take the wire from neutral, because in the industry also there is a single phase appliances is there. So for that case they take the power from single phase. Okay, that's all for today's class.